Hello everyone. So today we're going to be doing Leetcode's 128, longest consecutive sequence. The problem says, given an unsorted array of integer nums, return the length of the longest consecutive element sequence. You must write an algorithm that runs in O of n time. So in the first example, you have a list called nums that holds 100, 4, 200, 1, 3, 2. And it returns 4, and that's because the longest consecutive sequence is 1, 2, 3, and 4. In the second scenario, is 9 because it goes 0 to 8, including 0, so it will return a 9. So there are multiple approaches to solve this problem, but however, you need to make sure you account for the criteria, which is O of n time. So if you were to just to sort this problem, which is a pretty easy solution if you do, so 100 for 100 for 200, 1, 3, 2. If you were to sort this problem, it will be a pretty easy problem to solve. However, keeping this time complexity might make it a little bit hard. So you can't just sort it because sorting takes O of n log n. So we want our goal is to have a O of n time complexity. And to do this, we want to just throw this whole list into a set. So if we were to throw this whole list into a set, we can reference it pretty quickly. So when we throw this into a set, it'll look something like this. And we can reference the numbers really fast. And the goal is to figure out how can you keep track of a new sequence. And the answer to that is to check for I minus 1. For example, if we're at 100, if we look for I minus 1, which is 100 minus 1, does 99 exist in here? It does not exist. So we know that this is the start of a new sequence. So let's put seq for sequence. How about 4 minus 1? Does 4 minus 1 exist? Yes, it does. It exists right here. So it's not a start of a new sequence. How about 200? Does 200 minus 1 exist? No, it does not. So it isn't a start of a new sequence. How about 1? Does 1 minus 1 exist, which is 0? Does 0 exist in the hash set? It does not. So this is another start of a sequence. So we have 3 sequences in here. Because for 3 minus 1, there's a 2. For 2 minus 1, there's a 1. So we have 3 sequences. So let's start off with 100. So basically, we'll have an if statement to keep track of the sequences. And basically, the if statement that you would use would be if, see if I can make it a little bit larger for you guys. Seems like this is the largest I can get it. Let's see. Okay. So if not I minus 1 in hash set, the length will be 0, right? So we set the length to be 0 is because we want to keep track of a new sequence. So that goes right here. And now is when you actually start incrementing the length. So you start incrementing the length. We can think of multiple ways to do it. But for me, the most intuitive way is taking I plus length and checking if that exists in the hash set. And if it does exist, we increment the length. So for example, let's take account for what the actual answer is, 1, 2, 3, 4. So this is a sequence. So we're going to take the sequence right here. So like I said, we're going to make a while statement. While I plus length and hash set, length plus equal 1, right? So what that does is it checks, does 1, so length is currently 0, right? So does 1 plus 0 exist in the hash set? Yes, it does, as 1 plus 1 exists is right here. How about now the length increments up, so the length will be 1 in this first scenario. So now the second scenario, 1 plus 1, because the length is right here. So does 1 plus 1 exist? Yes, it does. because 2 exists in the hash set. How about 1 plus 2? Does this exist in the hash set? Yes, it does. 3 is in the hash set. How about 1 plus 3? Does this exist in the hash set? Yes, it does. So yeah, that's the approach I'm gonna be going with. How about 1 plus 4? Does 1 plus 4 exist? Does 5 exist in the hash set? No, it does not. So we know that the best length we got was 4, right? And right here, the length was 3, and the length was 2. Actually, the length was 4 here, sorry. Length was 3, and the length was 2. So that's how we're gonna be incrementing our length. So we're gonna have a variable called best length, or max length, you can call it whatever. We're gonna initialize it to 0, and basically we're just gonna take the max of the length and just return the best length. So we can now start coding this up. So like I said, we're gonna have a best length equal to 0, and we're gonna want to throw nums into a set so we can quickly reference it. So we're gonna do, let's call it hash set equal set of nums, and we'll iterate through the set. So for I in hash set, and we're gonna do this line of code right here. If not I minus 1 and hash set length equal to 0, if not I minus 1 and hash set, the length will equal to 0. So this is the start of another sequence. And inside the if statement, we're gonna have a while loop where while I plus length is in the hash set, you increment the length. So while I plus length in hash set, length plus equal to 1, right? And now you want to take account for the best length. This is when we use our best length variable that we just created. So best length equal to the max of best length and length. And then outside of the for loop, you can just return the best length. And if I typed everything incorrectly according to this, we should not have any errors. And yes, it looks like it works. Let's submit this code and see if it passes all test cases. And yes, it does. And this is O of n time complexity, which meets the criteria. And I believe this is the most intuitive way to solve this problem. So thank you very much. Subscribe for more videos.